What's up, guys? Today we're going to be solving one of the most classic problems in LeetCode. It's two-sum. This is a question that's going to be asked in many low-level interviews and some classes. It's a very, very classical problem. So let's go ahead and understand it fully. All right, so instinctively, you're going to probably go ahead and say to yourself, well, this is an easy problem. All I have to go ahead and do is iterate through the array once. And at every single number, I'm going to go ahead and check every other number. And if I find a number that complements the first number that I'm checking and adds up to the target sum, then I'll go ahead and return it. So this works. The problem is that you're going to go ahead and iterate through the entire array once, and at every single number, you're going to go ahead and iterate the array another time. This is an O of n squared complexity, which makes it very bad and very slow. Most interviews will not want this, and you're going to end up failing your interview if you answer this way. The way to go ahead and think about this would be to make some sort of fast retrieval system like a hash map. So you create a hash map and you go ahead and you put every single value inside your hash map, and then you just try to find a number that adds up to 9. But a faster way of doing this would be to build the hash map and at the same time check if you found the complement of the number that you're on. So what do I mean by this? Well, first of all, you're going to iterate through your array normally, and at every single number, you just add it to the hash map. So let's say we're at 2, we add it to the hash map. And then we go to the second number and we say, okay, before I add it to the hash map, let me see what the complement I need. So what number do I need to complement 7 to get 9? And the answer would be 2. So why don't I go ahead and before adding it to the hash map, I just check if 2 is inside my hash map. If it is, I return the indices of both numbers. If it isn't, I just end up adding it like normal. The reason why we do it like this is because, the worst time complexity is still O of n, so linear time, but if we end up getting lucky and both numbers are right next to each other in the beginning of the array, we can return super fast. So it will be like in 2 operations, which makes it much faster than putting every single number into the hash map and then starting our lookup process. In Python, it would look something like this, where you first have to go ahead and initialize your hash map. Then you got to go ahead and loop through your entire nums list. Then you go ahead and calculate your complement according to the number that you're currently on. After that, you just have to go ahead and check your hash map to see if your complement exists in there. If not, then you just return both indices. Remember, in this case, for our hash map, our key is going to be the nums I, and our value is going to be the index of the nums I, so that we can easily return it when we want to return our answer. Next, we got to just set our base case where we have nothing, so we iterated through the entire array and we just couldn't find a pair of indices that add up to our target. And there you have it. Using this approach, you get great runtime complexity. Our space complexity is O of n because we had to go ahead and make a hash map. Usually people will favor a faster time complexity. Guys, if you found this helpful, please go ahead and leave a like and subscribe, and I'll see you in the next one.